We're going to spend 2 days on this section. So this is solving logarithmic and exponential equations.
Will this be on the quiz?
This won't be on the quiz. So this is 8 dash, or 3, sorry, I keep thinking we're in chapter 8. 3-4a. And we'll call this solving exponential functions. Solving exponentials. And this is based on some properties. Okay, so if a to the x equals a to the y, what can you say about x and y? What has to be true about x and y? Y equals x, or x equals y, right? So if this to this is equal to this, then those two things have to be the same. And you use that a lot when you're solving exponential equations. Logarithmic equations is log base a of x equals log base a of y. And also x, if then x equals y, right? And so that's, oh, and also a couple other things you should know is that a log base a of x is equal to x. And conversely, log base a of a to the x is equal to, and I already told you these things. What's that equal to? X. Because these are the undoing, they're inverses of each other. So log base a of x is the inverse of a to the x. So if I raise something to that power and then I take the log of it, I'm going to end up with what I started. And in your book on page 210, okay, there's a bunch of, I would look these over like when you're doing your homework. There's a bunch of like very simple solving log and exponential function problems, but they're the basic ideas that you need to be familiar with before. I actually have it. I found it. Where is it? I have to find it. 12A 3-4 notes. Oh, look. There it is. Look at me. I am on the cutting edge here. No. Yes. Yes. Click on the quiz. Oh, shoot. Now I'm going to lose my notes. Oh, well. Oh, I stopped recording? Is that what I did? Oh, well. What happened? There we go. Come on. Yes. Yes? What do I want to do? Save this in pre-calc 13, chapter 3. Save. All right. So this little thing that they give you in your book is kind of solving simple exponential and logarithmic equations. So if 2 to the x equals 2 to the 5th, then x would have to be equal to 5. If log base 4, so this is kind of using those two properties that I just gave you. This is pretty obvious. If 3 to the negative x equals 3 to the 2, then negative x equals 2, right? And x would have to be 2. These are using the inverse properties, as is this, as is this, and as is this. So these are kind of those properties that I just told you about. And so those are useful when you are solving log equations. So moving back, we're just going to work through some examples of log equations. Oh, maybe I should open up my notes again. Where'd that go? Notes. Am I still recording? 3-4. Where's today? Updates. I don't know. Let's just go. Okay? So example example. Solve 2 to the x. So I'm just going to give you lots of examples. 2 to the x equals 32. And they say solve for x. Who can tell me how to do that? How could I rewrite 32?
X equals 5.
Yeah, I know, but how could I would say, how could I rewrite 32? Sam?
Log base 2 of 32.
Yeah, you could do that, but just write it. 32 is 2 to the 5th power, right? Okay? So if 2 to the x equals 2 to the 5th, then x equals? X equals 5. Okay? So sometimes you have to be kind of clever. Say, how can I rewrite this to make it match, have the same base as that? And that way, I can solve it.
Do you have to rewrite it like that, or can you just solve it right off the
Could you solve it right off the bat? I don't know if you get it wrong and you don't get points unless you show work. But if you got it right. Okay, what if I said solve? Let's change colors because this isn't very good. Pink. Let's say solve. 4e to the 2x equals 16. So if you see something like that, just do it like you're solving a normal old algebra equation, but you kind of want to get the e to the 2x by itself. So first thing I would want to do probably is divide by 4, okay? And that gives me e to the 2x equals 4. Who knows what to do now? I do. Okay, so what you want to do if you see something like this, you could rewrite it in logarithmic form, or you can take the log of both sides. You're allowed to do that. I'm going to make this different colors so you can see. Try to make it a different color. Natural log of e to the 2x, natural log of 4. So log both sides. You don't have to, you could do base 10 log or you could do natural log. It doesn't matter. It's the same answer either way. Okay? Because what is the natural log of e to the 2x? Oh, you wouldn't want to do log base 10 because that would make that disappear, right? You want to do natural log. So what is this equal to? 2x equals natural log of 4. So x equals natural log of 4 divided by 2. And then you can just plug that into your calculator. If this were non-calculator, they say leave it as an exact answer. We do it like that, but in this case, you could plug it in your calculator and get 0.693 about. Questions? Got it, Monica? Okay. What else? More examples. So then they get just kind of boosted up a little bit, and they'll say, 5e to the x plus 2 minus 8 equals 14. What do you think you should do first? Add 8. Very good. Okay. So you just kind of solve them like you're solving equations. And then it kind of ends up looking like that other thing that we saw before. Then what? Divide by 5. Divide both sides by 5. So now you get e to the x plus 2 equals, I would just leave it as 22 over 5 for now. Then what do you think you need to do? ln both sides, right? So ln, which gives me, so I wouldn't plug into your calculator until the very end, because that way you avoid like rounding errors and stuff like that. So now I have x plus 2, because natural log of e to the x plus 2 is just x plus 2, equals ln of 22 over 5. And then I subtract 2, so I get x equals natural log of 22 over 5 minus 2. And then you can plug that in your calculator. Did I do that? I did. And I got negative 0.518. Right? Yes? No? And the other thing that you should know is I can do these things I can do it graphically as well. Because if I'm using a calculator anyway, And a lot of times you should kind of get used to this process of doing things graphically because they let you use graphic calculators, like on the AP test and stuff like that. So what do you think general picture of 5e to the x plus 2 minus 8, what do you think it's going to look like? About? Where's it going to have an asymptote? Here, okay, because e to the x usually has an asymptote at 0. So it's going to be shifted down 8 units, and I don't know where it's going to cross, but it's kind of going to go up like this, something. And then, so if this is y equals 5e to the x plus 2 minus 8, minus 8, then what is this? This is like saying y equals 14, right? So then you would graph the line y equals 14, and you would do the intersection to see where they cross. Do you want me to show you how to do that with your calculator, or do you guys know already? Do you want me to show you? No, you're okay. So you could just do the second calc intersect, and that point should be, whoops, I'm probably off. It should cross somewhere on this side, right? Because that's x equals negative 0.5. Yes, sir? All right, so that's that. What if I saw something like this? Aren't these fun and easy? Let's do it in green for CSU. 2 to the 3, whoops, that's really good.
Are you going to tell us what's going to be on our quiz?
I did already. Section 3.1 through 3.3.
I mean, like, you said you were going to, like, give us some...
Well, those problems where I did the graphing by hand, the exponent, that's the one thing I think, that you might have to, that it wasn't really on most of your, I mean, you did it on your homework, but a lot of them, I looked at your homework and said, do this with a calculator, so you should know how to do that by hand. Easy? What do I do first? Divide by 2, right? Divide by 2, divide by 2. 3 to the x minus 1 equals 5. Add 1, 3 to the x equals 6. And just to show you, you can do either the natural log or the base 10 log. Let's just do the base 10 log just to be different, which they call the common log. 3 to the x equals log base 6. Now what should I do? Here's something we haven't done yet. How do I get that x by itself?
Bring it...
Yeah, you can roll the log, okay? Bring this in front. So now I have x log 3 equals log 6. So x equals log of 6 divided by log of 3. And then you can plug that in your calculator and get an answer. Do you follow what I did? Questions? All right. One more, and then a word problem, and then we'll be done. So this next one is kind of tricky. You gotta know. You gotta kind of be familiar with it. Like when I first got this stuff, I'm like, I don't know how to do that. But then I've seen enough of them where it becomes e to the 2x minus e to the x minus 20 equals 0. Okay? Any ideas?
I have 20.
What do you think, Keegan? How do you know that? Okay? He just knows everything. Okay? So that's what you do. Because what's e to the x times e to the x? E to the 2x, right? So what Keegan said, and it's kind of, right, you could let a use substitution, or we could just let y equal something. Let's let y equal e to the x, okay? Then y squared would be what? E to the x times e to the x, which is e to the 2x. See? Because e to the x times e to the x is e to the 2x. then I could rewrite this as y squared minus y minus 20. What does that look like? What kind of problem is that? It's a quadratic which you want to factor, right? To y minus 5 plus 4, right? See? And then either y equals 5 or y equals negative 4. Well, you're not done yet, okay? Because what we let y be, we let y, so now you back substitute back in, and you say that e to the x equals 5, or e to the x equals negative 4. What's true about this one? What's my answer in this case? No answer, right? No solution, because you can't raise e to a power and get a negative number, right? There's no power that I could possibly raise e to and get a negative number, so it's not in the range of the function. But e to the x equals 5 you can solve by taking the natural log of both sides. So natural log of e to the x equals natural, that's whose stinky tea that was. I smell like I'm drinking, but I don't like tea. So then you get x equals natural log of 5.
Can you do 5 to the 1, 5 to the 4?
Say that again?
Never mind.
No, you could.
Never mind.
Okay. So if you didn't want to go through this use substitution, you could have recognized this. I mean, what I did, I just went directly into it. I said, well, e to the x is e to the x times e to the x. So I just directly factored it to e to the x, minus 5 plus 4. I mean, you could, if you know that that factors to that, you can do that, but you could also do use substitution, or y substitution. They call it use substitution in calculus, so you still better do, but we're in that. Got it? Questions? Okay, and last thing, which is kind of a good application problem. So suppose you invest, if you invest some amount of money, invest P dollars at 8%. How long? Compounded continuously. Take your investment to double. Say there's not enough information. Is there enough information? What's the formula for amount invested continuously? PERT. Very good. PE to the RT. Okay? But in this case, it doesn't matter how much you invest. So if this is P, what do you want A to be? 2P. Okay? So the way you set this up is you want it to double. 2P equals P, E to the RT. And what E raised to the RT, not E times. And what happens to my P's? Go away. So I get, and I know R as well, right? So I know 2 equals E to the 0.08t. And then if I natural log both sides, natural log of 2 equals natural log of E to the 0.08t. And so that gives me 0.08t equals natural log of 2, and t equals natural log of 2 divided by 0.08. And if you plug that into your calculator, for t, you get t is about 8 8.66 years. See? That's why you should start investing now. Because you'll be rich in 32 years. Because your investment will double every 8.66 if you make 8%. That's a pretty high interest rate. So anyway, that's about all I have to talk about. I was recording that whole time. It works. Yay.